Shucks, I thought maybe I would get to go last for being not in person, but that's okay. So introduction, my name is Ryan Quint, Senior Manager here at NERC. I coordinate our inverter-based resource performance subcommittee. My relationship with GFM is a touchy relationship. We're on and off at times, a love-hate relationship to some extent. We don't understand each other very well. But we're getting closer. We're growing closer together. So we'll leave it at that.
That's awesome. Thank you.
And she has multiple partners as well.
Daniel, you're next.
Yeah, hi. So my first contact with grid forming was maybe in 2014. I was standing at a conference, wind integration workshop in Europe, and introduced some research about grid forming in wind turbines, and nobody understood it. Nobody asked any question, and it was maybe a bit early. And the technology and even the research was very immature, to be honest. After a few more years of research, I think we've come to the point where we should introduce the technology in a larger scale. And I'm really happy to have joined SMA last year and bring the technology to the market. That's my background on grid forming.
All right, thank you, Daniel. Mark?
Okay, so I'm Mark O'Malley. So at the moment, I'm Chief Scientist at ESIG. But I suppose in a previous life in University College Dublin, you did a lot of research in power systems. And I suppose my first, I mean, it wasn't with grid forming, but we had an inertia issue in Ireland, and it goes back to the 2000s. We started looking at it with people like Nick. And we did a lot of work on inertia, etc., way back then. And then since then, I've worked on a lot of things in power systems, and now all of a sudden the inertia issue is now, fundamental to everybody. I think that's what's happened. In Ireland, it was fundamental to us at an earlier stage. So I'm not a power electronics person, but I'm a power systems person, and my relationship with the grid forming is definitely not husband and wife or boyfriend and girlfriend, maybe second cousin or first cousin relationship. So I'm not a power electronics person. So my perspective is much more on the both power system side of things.
Jason.
Great. Hi, everyone. Jason MacDowell. I'm a senior director at GE Energy Consulting in New York, and also co-chair the reliability working group at ESIG with Julia, and really been engaged a lot with the industry, both from a manufacturer's perspective to understand where technology is going and the capability of technology, particularly inverter-based resources to support grid needs. So have a definite play in the industry to look at the capability of that technology and deploying that technology through code, standards, market mechanisms, but also from a system integration perspective. GE, together with Nick Miller and many of us at Energy Consulting, have really looked at what are the main gaps and issues with technologies going forward. And grid forming certainly being one of the biggest now is there's a lot of success in getting higher penetrations of inverter-based resources to be on the grid. And again, with our work that we're doing in ESIG, particularly around grid forming capabilities and defining what we need to have happen, working closely with Ryan and Julia at NERC, and with GPST as well. I think we have a really great momentum going on right now with defining what the system looks like in the future, what the needs are, and then building the capability with grid forming controls and actually deploying them out in the grid. So as I gave the panel session yesterday, as I opened a panel session yesterday, we weren't really talking about grid forming even a few years ago, seriously. We weren't talking about 100% anything a few years ago. And look where we are today across most jurisdictions around the world. 100% renewable, 100% decarbonization goals are there. And that's really what's driving a lot of the technology development at such a rapid pace. So I think now is an opportunity to really get engaged, and really great that you can be here and be part of this dialogue. Nick?
All right, Nick. And before Nick gets started, I actually seen that picture from the past century when Nick stands next to the grid forming inverter.
There we go. we need to dig that up. So yeah. And that was actually my history. So Julia, 1995, we did grid forming inverters on battery energy storage system for a 1.4 megawatt microgrid that was subject to not a wind turbine, but a violently fluctuating induction motor load that could at times represent almost 100% of the rest of the native load of this microsystem. So that was before grid forming was a word, but we basically, if you look at the IEEE paper I published in 1995, it shows essentially a synchronous machine phasor diagram and a diagram that would look almost exactly like what we have. So it was a virtual synchronous machine. We use IGCTs. Does anybody even recognize that? Right? 180 hertz pulse width modulation, you know, real nice, clean waveform, and not. That was a wild success. So they were able to black start the grid off the battery. It saved this community of about 1,500 Native Alaskans, excuse me, 250,000 gallons, 1 million liters of diesel fuel a year, paid for itself in a very short time. The batteries ran and lasted. They were supposed to last for 7 years. They were replaced after 12 years. And to the best of my knowledge, this system is still running in grid forming mode 27 years later. I've been trying to reach out to them, but they don't answer their emails. So I don't know whether it's that. So I have a long relationship.
Maybe they don't have power.
Yeah, well, they seem to keep the lights on, but they don't want to talk to me. So anyway, yeah, that's one of the joys now of being a gray beard is in the institutional memory of some of these things.
So we talked quite a bit. I mean, we actually started with this chicken egg problem, opening the workshop. So I wanted to kind of pass mic around and ask, what do you think is the right approach to getting to higher deployment, faster deployment of advanced inverter controls, grid forming including? And this time, I guess I'll start from Nick.
So you asked a bunch of questions. I'm going to zoom in on two. One that was kind of brought to my attention this week by Dustin from GE, and then again by Tybalt. The idea that we need to standardize capabilities. I think one of the healthy ideas that was kind of bashed around for the last 2.5 days is, for lack of a better word, buckets. So like the low hanging fruit and then the full shebang. Tybalt's presentation had that divided into 4 buckets. Dustin's had it in 2. I think that's a piece of the answer that's practically realizable. Let's not wait till we figure out how to do everything. Let's go ahead and move forward as reasonably quickly as we can. And insofar as it's necessary, let's not be completely technology agnostic. So this is Andrew Isaac's pet peeve, and I fully agree with it. Damn it, let's start doing batteries with grid forming inverters, period, going forward. Okay, we don't need to wait to have it all worked out for solar or even a little longer to have it fully worked out for wind. We got to have some give on that. So that's the first nickel. The second nickel is I've been doing a lot of work in the stability problem. So we've had a lot of discussion this week about individual systems going to extremely high. The reality is in North America, there's a nearer term, and ERCOT's got it, but it's with a vengeance in the Western and Eastern interconnection, where you have parts of the system, big ass parts of the system that want to have massive amounts of inverter-based resources, generally exporting. Okay. So all the high plains where we have, if you're not familiar with the US system, people don't like to live where it's windy. We have many, many tens of gigawatts of realizable wind resources. Power needs to travel hundreds and hundreds of kilometers across AC systems. Let's make sure that we get the attention to the stability aspect of regional high penetration. I don't feel like that's getting enough attention. And one of the ways to remove, in my mind, the barriers, the challenge for Unify and everybody else, is let's start doing some demonstrable exercises in showing all the early researchers, Deepak's work I'm doing with Telos for MISO, says that the stability limits go higher. You can get more power out of these regions with GFM than you can with other resources. Let's show that and show the economic benefit, right? We could put an extra, you know, whatever, 30% wind without more transmission. That is a driver that is highly compelling. And the industry needs to see from this community in this room, those kinds of examples to help remove the barrier. Why should we do it? 30% more power. Okay, those are my two nickels.
Next.
Sure, thank you. So again, resonate very much with what Nick just said, you know, in prioritizing the capabilities. And I think, you know, many of us in the room have contributed to the ESIG grid forming report that I think really outlined a lot of the very fundamental steps in identifying system needs, identifying system services, and step by step taking that and saying, what do we need to do to solve particular problems, and breaking the chicken egg cycle. And I think, you know, from defining the target system to developing and deploying specific requirements and capabilities of equipment for specific needs in the system is a very effective way to get to the low-hanging fruit, like Nick said. And again, don't try to fix everything all at once. Have specific demonstrations of specific services that allow you to move forward with control stability. That's one aspect. With capability to support other system needs like grid forming around inertia. That's a second bucket. Around black start, that's a third bucket. So we heard all of those different flavors, right? And I think having the defined system needs and services in place and demonstrating each one of those and their capability through pilots, as Nick said, right? And I think that is the way to move forward with it. But we need to do it collaboratively, like we're all saying, right? There's a lot of great work that's being done in this team, and many thanks to the contributors and authors to the report, including Nick, certainly Julia's leadership, Ryan, Deepak, and Andrew, and many others in the room. I really want to say thank you for that, because I think if we follow that cycle, we're going to be much farther ahead as an industry. But we need to do it collaboratively across all of the system operators, the equipment owners, the OEMs, the policymakers together. And I think that's the tall lift ahead of us with the speed that we're doing. But we have to get that right.
Who wants to go next?
Well, I suppose logical, I
Go
suppose.
ahead.
So I'm not going to add too much more to what was said, really. What I've got noted down here in my notebook actually is room for maneuver. You know, I think that it's very important that people are allowed to experiment and fail. I think that's pretty clear, which is, you know, it's just a new version of what's been said already. I've got perfection as the enemy of the good, which is, again, I think it's reflecting what's said altogether. Learn by doing, work together. So they've all been said. The one additional one that I would like to add is localization. I think from what I mean, again, it's not my expertise area, this, but from what I can see, I think a lot of the solutions will be fairly localized. You know, that's the impression I get. I may be wrong. And you need, although you're working together, you need to understand that there's a localization. It's not a global solution. There's a localization issue. I think you need to keep that in mind as well. I mean, does that make sense? Yeah.
Yeah, I would say catching up on the localization, it is important to look at the specific problems a certain system or part of a system has. And if we look at the UK, for example, there is an inertia problem and a short circuit level problem. In Australia, there are more issues with voltage stability or the system strength. And they have a specific service, not in operation, but there is like a commercialization is on the horizon for the next 12 months in both cases. And I think this is a big incentive. And at the same time, in both markets, a lot of batteries are being installed anyways, with or without grid forming. And I think this combination of batteries that are used for arbitrage or for shifting energy from midday to the evening, they are economically viable anyway. And it is even more attractive to invest if a paid service can be stacked upon. And this solves two big problems. One is the short-term storage to enable higher levels of renewable penetration. And on the other hand, it will also solve system stability issues. And this is a win-win for everyone. It's just the technology is new. So we have to work together, as you said, and get it running into the system. But the path is very promising, I think. Yeah.
Ryan, you'd like to add anything?
Yeah, I agree with what everyone said. I think the only thing maybe I would add from my perspective is I see reforming technology as a technological solution option to a set of problems, right? At the highest level, it is a technological advancement that can help us solve some problems. Where I think that falls apart is understanding how that can solve the problems, right? I think it's always good to recognize, keep ourselves grounded. Like the folks that are in that room right there are not a good representation of the industry, right? It's the brightest folks in the room right there, right? The best of the best coming together to try to fix the problem. But when you go out and you talk to pretty much everybody else, they don't understand what it is. They don't really know what it looks like. They don't know whether it's a fictitious idea or an actual in-service product. There's a lot of uncertainty, discomfort, and lack of education out there in the industry. And I think that's our biggest roadblock in my opinion. So, the planner's looking at it from, I need to fully understand this thing so that I can build a model and I can check that model and I can study it and I can determine if I can fix a problem with this specific solution option. Well, if I don't understand it, I'm dead in the water. If I don't have a good model, I don't feel comfortable with that model, I can't convince my management, my regulatory body, whatever, that this project can go forward. And then there's that economics piece that one of the panelists mentioned of, if I'm on the developer side, I heard make every BES a performing BES, right? Well, we're installing battery energy storage every single day now that is not GFM. And why is that? Right? Well, it's probably because there's an economic disadvantage to that. And so it's still very unclear how much economic disadvantage and what's the need for GFM today, right? Because it ultimately comes down to, well, if there's a reliability risk, we need a requirement. We need to shore up that risk with a requirement. But the other flip side is we need to be ready to proactively build a system that is prepared for high pockets of IBR or an entire system of high IBR, right? We're not the best at planning proactively for that system of the future with the current interconnection process we have, the current planning procedures, at least here in North America. And I think that's a big challenge that we have to figure out how to overcome to unlock that capability.
I actually wanted to pull on what Brian just said. We were supposed to have Julian Leslie from National Grid ESO here on the panel, but he couldn't make it. And for this particular question, what do you think is the right approach to wider deployment? I actually wanted to gather up some system operator opinion. So we have like AEMO, FinGrid, HICO, ERCOT here. And I was wondering, if you guys could provide some perspective, what do you think is the right way to, further deployment of grid forming capability or of new stabilization services? I mean, we heard in the workshop varying opinions. Some saying, "Oh, let's define services and incentivize it." Some say, "Let's require it as a grid interconnection requirement." So I was wondering if could any one of you reflect on that? What is the right approach? Is it require everybody have grid forming from now on? Is it define services, arrange markets? What do you think will work best?
All right. Hope you can hear me. I'm not sure whether it's a right approach or not, but this is something I could think of. I'm not going to talk about the incentive because that's not my area. What I have been watching for the last 2 days, that which is the largest grid forming battery someone has trialed somewhere. Okay. I think it was 20 megawatts somewhere. I listened earlier today. Yeah. No, I'm talking about the trial of various, let's call it a trial under certain conditions, right? I think we probably need to start thinking about, because this grid forming, what I've been hearing is, let's call it no regret solution, right? It is going to provide non-negative benefit to the grid. We need to start thinking deploying at few hundreds of megawatt in the grid. Start from this technology at grid scale, seen for the last 3 days, a lot of trial in a laboratory environment or isolated grade. But if we really want this technology, we need to thinking have an appetite from operator, from OEM, from the participants to trial them and be brave and say, well, it might fail. We never know, but we need to start trialing this technology. Do we have a lot of hydros, gigawatts of hydros, gigawatt of coal? Someone has tried it, right? Put it in a field. Let's see if it works. So I think we might need to start thinking about it. Not sure whether that's the best way or not, but this is something I could think of.
This is Lee from HICO. So our experience is first from resource planning perspective. In order to realize a 100% plan, we needed to do a lot of DER. We probably do not have many options, but then in the planning perspective, we see this causes a lot of issue when DER displays synchronous machine. So we tried a lot of things, and then we find out that we have to do the grid forming inverter. We don't have many other options so far. So maybe first from planning perspective, we put that technology, realistic technology from direct provided by the OEM into the planning model, see what kind of benefit we can get from that. And then step by step, maybe next step should be working with Unifying to the demo, and then gaining more experience from peers, especially about operational experience, and then moving forward. Thank you.
Hi, yeah. So my question is, what was said was, we really need to trial at grid scale. And then additionally, with the interaction of DERs and whatnot, we know grid forming could provide solutions, but from a grid perspective, like PJM, if we want to put it on a big grid with synchronous generators, they would, from their perspective, they might undertake risk if they don't think that the technology has been trialed well enough. So what could we do to convince a grid operator that it is where it needs to be for a trial, for them to shut down part of their system, hook something like this up, and actually start taking data and incorporating it into their planning models? It's more of a question, I'm sorry, but.
Can I leap in on that? Because I have that.
It all got on hand, but.
Yeah, well, I just somebody, there's a couple of pieces of this puzzle. Part of the experience that HICO's done, and Lee's being unnecessarily modest, they've really done some remarkably creative things. I wanted to talk to commercial side. So, we're in this somewhat uncomfortable space. Who's bearing the risks? Where does the money come from? How do you make sure that the money is being well spent? So some of the creative stuff that HICO did to make sure that the competitive forces of the market were brought in at the procurement stage. So they basically did a spec and said, okay, we're going to make sure that there's lots of bidders on it, but it's going to be the competitive and the watch out for the consumer is done at the procurement stage, not trying to make the money back on selling services downstream. All right, so that's one route forward. I'm not saying that's a one size fits all, but they did a good job of guarding. The other piece fits, I think, this latest question and something that Mark just said, right? A bunch of, and what Ryan's worried about, right? You got a bunch of grid needs, all right, that are really grid reliability needs, not generation resource adequacy needs. And as the industry has a real hard time with resources that wear multiple hats, right? It's this, is it fish or fowl? If it's a generator, then it's got to justify its existence on the market streams that are associated with the generator. And there aren't good mechanisms to give it credit for having the right capability in the right place. And somehow, from a regulatory point of view, one route forward, and I'm not a markets design person, but there's got to be like a mechanism to like cut off a chunk. Say, look, we're going to get a regulated rate of return for 20% of the capital cost of this project because it's a grid asset. And then the rest of it is a market. So we aren't forcing resources to be fish or fowl. You still get the right market signal and you get a signal it's coming in the right place because there's so many locational aspects. We don't have a path forward to make that happen. And I think that that's an important part.
And Jason, wait a second. I think Nick is alluding to my next question, which was interconnection requirements versus services. What are pros and cons? So we can go ahead with that.
And that's where I wanted to allude to it. And Jonathan, I think I wanted to point out some of the good examples specifically of how to balance interconnection requirements versus services. And we landed here anyway. And I think there are some examples where that has worked well. ERCOT being one of them. I think National Grid UK, another example in Ireland, the third example, where, I'll pull on this and maybe Jonathan and Julie, you can talk more about it, but the RRS is one good example where you have qualifying resources that can provide frequency responsive support. And those resources have to have minimum capability of performance, but then how much do you procure goes through the procurement in the market. Right. So I think the answer to, at least as far as I can see in many areas where it works well, to requirements versus services is yes, both. Mm-hmm. And having a minimum level of specification of performance that's needed for qualifying resources in a grid code, in a requirement to say, okay, this resource has capability to provide inertia, has capability to provide grid stabilizing effects for voltage support, dynamic voltage support, or black start. Right. All of those things are services that can be defined with a minimum level of performance. But then to answer Mark's question about localization, you've got market products that incentivize those services to how much that you need in any particular system in any particular operating condition. So I think that mechanism works well. And Nick alluded to it. We don't have that really nailed down yet in every system everywhere. But thinking about it like that really allows the manufacturers to say, here's the performance we need to build to. 2800, for example, kind of does that as well with minimum specification of performance requirements. But then, all right, how do you actually procure it? And in what system conditions do you procure? So I think
so it's a little bit towards what Carmen was talking about yesterday. You have kind of minimum grid forming capability, but then there is a market where you can kind of make your money back for having this capability.
Right. And the nice thing about that is that you can specify, quote, grid forming with each service, inertia versus control stability versus black start. And all of those have separate paths and separate markets. So you don't have to fix everything all at once. You specify how much.
Right. I wanted to give a word to Jonathan to bring another system operator's perspective.
Okay. So I'll say that this right now is just my perspective. I haven't talked with other ERCOT people, but we have at ERCOT, we've had a lot of success by actually mandating things that have been a little bit of a stretch for the industry. We required wind farms to do voltage control and reactive power management, I think back in 2003. And we didn't, it didn't matter whether you were in a weak part of the system or a strong part of the system or a part that needed reactive power reactive power. We just said everyone has to do it. And, 2 or a couple of years later, you really couldn't even buy wind turbines that didn't have that capability. It wasn't really that much of a stretch at the end. And we sold it based, it's a stakeholder process. We can't just command rules, but we sold the idea that this is going to prepare the system so it will be a better place for everyone to connect in the future. So now talking about, and we've done other things like voltage ride-through, kind of a similar response. Where yes, but the voltage ride-through and the reactive power requirements, which we see as control features, they don't require withholding or anything. It's kind of a lump cost initially, so it wasn't something we worried about compensating. We just made it a requirement. Now, thinking about the grid forming, I'm going to come back and be actually a little bit more bold and just propose that we kind of go for it. Let's say, propose to a stakeholder group. 2 years from now, we want everyone to bring some kind of grid forming to the system. I think this will be great because there's actually different kinds, different manufacturers have focused on different ones. Let's bring them on and see how they work. And I have kind of quite a bit of confidence to do that. I know this sounds really bold. Let's just open the gates. But in ERCOT, we rely a lot already on our EMT models. We have a lot of series capacitors on our system, and we rely very heavily on studies that show wind turbines, other inverters behave well with these series capacitors. And we use, these are black box models. We can't look inside. Every manufacturer's approaching that problem very differently. A lot of them designed their control systems for ERCOT and our series capacitors, and then other regions, other places around the world, wind farms started wanting to connect near series capacitors. But we have had hiccups, but by and large, that process has worked. So I don't feel it's that much of a stretch, and it's that much to need to be feared for. If it's something you can model, and we're already doing a lot of EMT modeling, you can show it works. Let's begin. Maybe you do sensitivity, so if something goes wrong, you know it's okay to turn it off. But that's my 2 cents.
All right, thank you, Jonathan.
Yeah.
Jonathan deserves a round of applause. We'll move on to next question. I will take if you can hold that thought, we'll have 20-30 minutes at the end. But please remember what you wanted to say, because I want to leave some time for us all kind of to chat towards the end of the panel. I'll probably move on to the next question, and it's kind of related to the previous one. And I'll start with Daniel this time. Should grid forming be a standard set of capabilities, or should it rather be kind of, on the other hand, based on system needs, and kind of let equipment come and provide bits and pieces like they had, like you've seen in previous presentations, there are different buckets of capabilities. What do you think is the good approach?
Well, I think it depends a bit on the issue on the system. If we look at let's say issues that are mostly related to, for example, voltage quality, it is straightforward to solve it with, if it's grid forming or not, it can be solved by PV resources, by wind resources, or by batteries. But if we look at anything that requires an active power reserve, for example, or an overcurrent capability, I think it's not very straightforward to implement it on all the plants in the system. No matter if it's required or not, because it will cause effort and cost, and those costs should only be caused when they are really necessary. And I think for that, for those aspects that really add cost to the installation of those new plants, they should be directed through a market, because it will result in a more efficient design. And getting back to the question, which technology can do it, I would say, for example, for inertia at the moment, the only mature technology is battery systems with grid forming. And so it would be quite difficult to ask for inertia from a PV or from a wind resource. It is more or less experimental in that field. And it would cause a lot of discussions in the negotiations, let's say, within the industry, which maybe have to be done to find the best way, really. So we are, of course, open to discuss also grid forming with solar plants as an OEM. But I think those discussions will take quite some time as compared to for a battery. If there is a market incentive, it is available technology at the moment.
Right, I'll give it to Ryan. So standards on grid forming, inverter-based resources, or separate requirements for each service, and let resources provide as they can.
I agree with the last couple of commenters. Jonathan's comments resonated with me quite a bit, right? I think we need to think big and bold. Exactly what the solution is there, I'm not sure, but we talked about bucketizing, and then we talked about, well, can we just have a standard set of capabilities, those kind of things. I think we need to just sort of think long and hard about, are we overcomplicating this to some extent? That today's modern technology can do a whole lot of stuff, right? So I go back to the fact that this new concept of GFM is another technological advancement that serves as a solution option, right? So again, I go back to, at least in North America, now some of the things that have been talked about so far are not so relevant to North America. We either have the generator interconnection process, which is independent power producers trying to make the greatest rate of return they possibly can at the lowest cost, right? So you disincentivize any add-on bells and whistles entirely through that process, right? The generator gets paid predominantly for megawatts, and so they want to maximize megawatts. Now, as Nick mentioned, there's a big economic value to, I'm going to use GFM because I can increase my capacity 30%. That's a no-brainer to a developer. There's no reason why they wouldn't want to do that. And there's no need to incentivize that or bucketize it specially. They're just going to make more money, which is ultimately their end goal. On the other end of it, we have the transmission reinforcement, either through the generator interconnection process or through the transmission planning process, right? So that question turns to, well, we have a whole lot of parts of the country that are constrained from a transmission perspective, right? I can't easily build new transmission, but I can easily drop in some batteries that could mitigate thermal overloads, whatever those issues may be. And I, as the utility, am incentivized to make that transmission infrastructure build as expensive as possible to the extent that my PUC will allow me to, because I get a guaranteed rate of return, right? So it's a no-brainer that the transmission entity installing batteries would want to add GFM, particularly if it costs more money, right? Now, ideally, there's some economic benefit, and that's why we have regulatory bodies, because we're incentivized as a utility to spend as much money as possible. But it seems like there's a whole lot of drivers right in front of us pushing for GFM, right? And I think we get lost in the weeds sometimes around creating these really complicated buckets that policymakers that are oftentimes, I just spoke to a policymaker the other day, and he was a geologist. I've spoken to one in the past that was a zoologist, right? Those are the people making the decisions, right? When we overcomplicate it, they don't understand, right? So can't we just say these things can do a lot, and there are various solutions that need to be solved, but where is the policy gap that's going to drive that innovation? I think if GFM was really, if transmission entities, for example, were really, really comfortable with GFM, we would be seeing them pushing for using it as a solution option on their side, because it's a whole lot cheaper and easier to slap down some batteries than it is to build transmission infrastructure, right? And so if I can build a whole lot of batteries at reasonable cost, then there's a good opportunity there that we're going to see a lot of GFM coming from transmission as a transmission solution option. Same thing holds on the generator side. So it was a roundabout way of answering the question, Juliet. Maybe didn't answer it directly, but hopefully spark some thoughts.
All right, we'll go to the next one. So we heard about kind of system operators applying a little bit of different solutions. Some say German system operators probably going to trial it as a transmission asset first and get some experience. I think we heard from Thibault also kind of same type of thought. But on the other hand, say from Deepak's presentation, we heard that solutions are kind of highly customized, and it depends on the system, where you need it, how much you need it. So my next question was, what do you think is a good pathway so that system operators can learn from each other experience rather than each reinvent their own wheel? So what do you think is missing, for that to happen? Anyone? Jason, want to go first?
I suppose it's beside me. I'll start. I mean, I don't think there's anything missing. I think we're doing it here today. I mean, I think it's more of these type of things. That's a simple answer. I don't have anything more to add to that. More.
Yeah, exactly. I think having more of these open collaborative platforms is the key, because I think if you think about how the commercial process works for deployment of generation through the interconnection process, those tend to be very tricky discussions between different entities that are competitive. But I think a platform like ESIG, a platform like GPST, to have open discussions about system needs and capabilities for manufacturers and how do we deploy it through equipment owners. Those are the types of collaborative platforms that we really need to foster and talk a lot more directly about, you know, all the capabilities, needs, and mechanisms in order to deploy it. Obviously, there's consortiums like Unify that help push that forward. But I think the one thing that I'll kind of wrap up with, you know, at the end as well, is we need to take definitive next steps. We all talked about these capabilities and these platforms, and I think defining exactly what we need to in each case to deploy it is something we're still working through in GPST, and having really good definition of that is the only way we're going to move forward. So we really would love to have more participation from all of you in that. You know, just keep watching it, because we're going to move quite quickly going forward.
Yeah, so I mean, this is maybe a bit premature, but I'll say it anyway. So within the GPST, we are just in the process of setting up a technology council. I won't go into the details of what that means within the GPST, but the idea is to bring together OEMs, system operators, developers, and some others, I would suspect, probably regulators as well, you know, because they're involved, and to deliberately try and, well, actually, the goal will be to operate a power system at 100% IBR. That'll be the goal of the Technology Council, and the system operators will be involved in that. Now, whether we actually physically get to operate a real power system at 100% IBR is not you know, it's a sort of an aspirational goal, but in trying to do that, you'll probably solve a lot of the other problems that people existing have. So we're just in the process of doing that right now, and you'll see more of that in the coming months. Nick is quiet.
You want to-
I'll be quick. I agree with all this, but I also want to echo Ryan's concern. So piece of this puzzle, and you know, you mentioned you may have regulators. We also got to make sure that we don't overcomplicate. We got to get this, the narrative, really simple. And you said some wise words about trust. Some of this is trust, but you need to be able to make it a cartoon, right? that resonates and is understandable. And those of us that understand, you know, the answer amongst us nerds that it's really complicated is certainly true, but it's not that useful.
Sorry, I want to add something else. So just one thing to add, I mean, I think we're overcomplicated. I mean, it was mentioned yesterday. So Julian gave a very good talk yesterday, and you know, they have their Pathfinder, and what they've done is they've essentially given 10-year contracts, and the idea is that slowly but surely these will become classic market products. That's the intention. But actually, if you think about it, so I was talking to Richard Tibords, who's down in the other session. I don't know if everyone knows Richard, but you know, he published a famous book with Fred Schweppe, I don't know, 40 years ago now. You know, if you try and put a market, and we've just said it's all localized, you know, it doesn't stack up. You know, localized markets don't work, and these are localized solutions. So I just have this impression that this idea of pushing it all towards a market may not actually work, because the market won't be liquid. So I think that's, and I think trying to make it work could be very complicated. So that's just my penny's worth.
Okay, so when we look further at the UK market for the Pathfinders, I think there have been like 230 submissions. So I think it is quite liquid, because only 10 of them got it. Okay, it's a 10-year period, yeah, but maybe that's the way to go. Yeah. Or maybe it's a 1-year period. It doesn't have to be day ahead, because you cannot build a battery within a day, but you can build it to last for 10 years easily. Sure.
My concern is that I think that there was impression given that it will become a day ahead product, and I don't think it will. That's all I'm saying.
Right. Ryan, you want to add anything here, or we move on to the next slide?
I think we're good to move on.
All right.
Julian,
One thing I would throw out there though is, I think Julia, you started with, how do we build confidence so that, not everyone has to feel like their system is a little different, right? And that's what I caught on to. The industry at large, I say, is typically averse to standardization to the extent possible. And we see that in policy proceedings, particularly here in North America, where all the large ISOs in particular will chime in proceedings and say, my system is different. I want to do it my way, right? I don't standardize anything. Let me do my special thing, right? And that kind of kills some of the stuff we've been talking about, or is a hurdle that we have to overcome, right? So when we all talk about like standards and things like that, we're getting big pushback from the system operators directly saying, I don't want standardization. I want my system to be unique and special, right? That realistically at a policy level, that's what we're up against.
I think I'll jump over one question. I think we already talked about that. The next question is, if you have to name one barrier that you think is the most like pressing barrier right now in deployment of grid forming inverters, what would that be? And how do you think it can be overcome? Who wants to start? What's the main barrier?
So, I mean, I think, and again, I'm only going on what other people have said here. I mean, and Ryan just brought it up, is the education one that was mentioned in the previous session, etc. And I come back to my comment in the previous session. I think if you try and educate people, you'll fail because it's impossible. So I think the barrier is, I think we just have to force it, if you know what I mean, if that makes sense. You just have to say, look, this is what we got to do. And if they say, explain it to us, say, look, I could explain it to you, but you're not going to understand. And so, let's just get on with it. I mean, I don't know. I mean, I just think you have to force it. I just think you have to force it. I don't think there's any other way. And that's a barrier. And the solution is to be fairly determined about it.
So I wholeheartedly agree. And I wrote down one word, the answer to this question, and it's awareness and trust. And I think the way that we can show and build awareness and trust is show it works, is demonstrate that, hey, we've got a solution for this. We've got grid forming, and we've heard over the last couple of days, the last few days, it already works, right? We've got grid forming resources that are currently providing the services that we need. It's a matter of scaling it. It's a matter of showing that it works well enough for each system. And this is what we're talking about here. This is why, the working groups in ESIG and GPST and NERC and all of the other forums and Unify, I think that's what we're really trying to build, is scale that. But we're already there. We have grid forming resources that provide the stabilization effects, but it's a matter of showing that it is scalable and building that awareness and trust. It needs to happen ASAP.
I mean, just on a historical context, I mean, G is sitting beside me here, but I mean, Nikola, I always put Tesla in there first. I think he was more important, but Nikola Tesla and what's that guy's name? Thomas Edison. Yeah, that guy. They did, 125 years ago, they didn't go to policymakers and explain it, did they? Did they? They didn't. They just said, look, here it is, and look what it does. And that's it, So, I mean, history, I think what's happened is that this industry now has become so regulated and so part of politics, and that the policymakers are, it's become so fundamental to life itself that they have a huge stake in it. But when it started, they didn't have any stake in it. So I think you need to go back to the start and say, they just built it and it worked, and just get on with it. So I think the policymakers are getting in the way, to be honest with you, the regulators.
Someone else?
Yeah, I think it's just to confirm that again, it's about trust, and we are also like challenging the bare existence of the synchronous machine, which is like a 130-year-old proven technology, and we are saying we don't need that anymore. And of course, this causes opposition and some trouble, of course. But in the end, we have to prove we can do it. And I think with pilot projects, like for example in Australia within the ARENA funding round, there will be some pilots which are not under the pressure of having to be perfect from the first place. This is probably a way to overcome the barrier and gain this trust. Yeah.
I think maybe I'll jump in while the mic's being passed over. I mean, the trust is what popped into my head, and the confidence, the transparency, the clarity. And to Nick's point earlier, right? We need to be able to explain it in a cartoon. What I've heard, kind of as the discussion has transpired, we've got this idea that it's a solution, and it's got multiple categorical complex problems it can solve. That sort of leads to, okay, well, it's a multi-value proposition here. But I think that's still not good enough in today's world. I think where we need to get is, this is kind of to Jonathan's point, this is a no-brainer, right? And if we can say this is a no-brainer, then we have a really easy, it's kind of to Mark's point, just trust us here. This is a no-brainer. Like, let's get this going, right? And I don't know that we're there quite yet, right, with the technology and as industry, and we have a little bit of ways to go. I would, to be fair, okay, I'm a regulatory body, right? I work for a regulator. I would say that to some extent I agree with Mark's last comment there, but I would say not all regulators are trying to be barriers or roadblocks. I'm not a policymaker, so I'll blame the policymakers, not the regulators. But I think from our perspective, right, we write performance-based standards, at least in here in North America. From our perspective in the NERC role, right, there are no requirements, there are no standards out there that would preclude anyone from moving forward with a GFM project today, right? And if there was, we as an industry would modify that as quickly as possible so that there is no technological barrier to that progress. Now, there may be policy issues that are getting in the way, but not from a reliability perspective, at least.
I'm going to throw a smoke bomb into this discussion a little bit and be a little cynical and come back to blame the policy. I shouldn't warn you, huh? Just whack it out there, right? Okay. There's a lot of the regulatory structure has perverse incentives to over reward conservativeness and to reward the people that are in decision-making positions to spend money on capital investment that gives them a regulated rate of return instead of finding creative solutions to squeeze the most performance and the most societal benefit out of everything in the system. And if a wires company's got a choice of building $500 million worth of regulated rate of return new transmission, or fixing a problem by creative control and mandate and working with generators to provide some functionality, and this is anywhere near limited to grid forming inverters, the answer is, why should we do that? That's not in the interest of our our shareholders. We want to build this new line. Don't talk to us about that other crap. And it's a real serious problem.
And it's a pity Julian isn't here, but from what I can see in National Grid, because the system operator is determining it. And so I think they've solved it, because they seem to, the system operator has come up with the solutions, and they allow the network owner then to put in a counterfactual. So I think there are people working on it, but I agree with you. There is some perverse incentives in it.
Regulatory hurdles. I think one thing kind of that is similar but different, and we were talking about trust, and what you mean is like trust and equipment. But I think from my perspective, what I see listening to more proactive developers and more proactive system operators, there is also kind of lack of understanding what's already out there and lack of knowledge. And so I think like, maybe events like this, I was trying to bring experience from all over the world. So like people hear about this projects and OEM capabilities, because anecdotally, there is a very proactive developer, after we presented grid forming report, is coming up to me and saying, well, we are really interested, we're a battery developer, we're really interested to maybe consider grid forming. So who do I talk to? What do I do? Like, how do I find out OEMs that are, have capabilities? How do I have the right models to provide to system operator? On the other hand, like we hear from system operator, well, you have to provide to us generic models. There is not yet approved generic model for grid forming inverter, so I cannot accept your proposal to be grid forming because I cannot model you. So there are these barriers just based on lack of information, and kind of each group of stakeholders waiting and seeing what happens on the other side. Kind of from the manufacturer's point of view, they have a capability, but on the other hand, they don't really want to push for it hard enough where it becomes a requirement, interconnection requirement. They don't want to, go and now openly say, well, I can do everything and just go and require me do it. And then developers on one hand just want to build megawatts, maybe don't want to provide extra capability, and system operators don't know like what's even out there and what's possible, and have all sorts of regulatory hurdles. So we'll go to and I think we alluded to it a little bit. We'll go to, I'll make it the last question, open it up. I think there is a lot of discussion out there as well. We want to give some chance people ask questions. One thing, Mark, you pulled on at the end of last session is what is human capacity, skill shortages, and also combined with the second, and what is the role of universities and research in providing these new solutions. So like what we from the presentations today, system operators are already in need of this technology solution. On the other hand, there are a lot of research questions still out there and still not, being area of active research. So how do we, pull it closer together? What's the role of universities, and how do we get the right people to solve the right problems? It's a big question.
So on the skills issue, I mean, it keeps coming up. I mean, AEMO, I mean, when we're in this room, they tried to hire people in this room. I mean, it's, let's be clear, if there's nothing, and in discussions in the last couple of weeks, or it's continuously rising in discussions I have within GPST, with industry skills. I don't think we need more people. I just think we need better people. So I don't think this is a quantity issue, actually. I don't think, if you get I mean, I think you all know John O'Sullivan. He couldn't appear yesterday, but John O'Sullivan is worth 100 people who are, he's an A-rated engineer. 100 B-rated engineers will not be able to do the same. Quantity is not what you need. You need quality. I keep hearing it, and I keep saying to people in the industry, pay. It's just it. I mean, that's, if you pay more, you'll get them. Now, I mean, I'm not saying that people will, money is not the main motivator, but we're losing a lot of people in this industry to Google, Facebook, they're numerous people, and they can get much more if they work for those people. So, I mean, I think that's the answer there. The role of universities in research in this area, I actually think this area is going so fast now that, the traditional model, I mean, it's a little bit idealized, was that, the university research and then to go to industry. That was a sort of model. Well, industry do a lot of research themselves, obviously, but this is very much industry. I mean, I think the model is flipped on its head completely. And the universities have to sort of play a role of, I don't know, assisting the, it's not just we do the universities research pass on to industry. It's more the national grids of the world, ESO, are pushing things forward, and then the universities need to sort of back that up, if you know what I mean. Mm-hmm. I think that's the model that has to happen, and that's the model that GPST is adopting. So, and it's not because it's moving so fast. It's in fact, we said what grid forming wasn't even. 2 years ago we met him. In fact, it was 2 years ago, three years ago. Yeah, we had the famous meeting, the ESIG meeting of towards 100%. A lot of people in this room were at it, and it didn't even get mentioned. Isn't that right? And now look where we are. So I just think the universities now need to flip their thinking and say, we need to follow and assist industry. You know what I mean? Be sort of a, assist industry, as opposed to we do the fundamental research and then pass it on to the industry. I think that day is gone. We don't have the time to do it.
Maybe we can also look at what we can do ourselves. So maybe we should just educate more interns who are just started university. Maybe every one of us in the room could have more interns, educating them in power engineering in the widest sense. And on the other hand, to draw away people from Google or companies that have a lot of money, but not a very, let's say, nice mission. We have such a good mission to drive the world towards a carbon neutral future. And we should really use this also to keep the people flowing into our industry.
Yeah, but just to be clear, I mean, I'm not saying you need to match. I mean, I'm looking at Ben there at NREL, right? And I used to be with NREL. I still work closely with them. Mission does have an impact, but on the salary differences that are existing, it does not have that big an impact. There is, so I agree. You don't need to match it, but you need to go further than you currently are, basically. I think that's the
other thing I would add, on this topic. This is something near and dear to my heart, right? That something we focus on. We have been doing a lot better job focusing on internally within NERC with our new CEO. The utility industry comes from an older mindset, right? Old school way of thinking, right? It's in some ways, yes, yeah. If folks go to Google or Amazon or what have you, right? They get a 40-50% pay bump, but they also get a lot of perks and appreciation and management that cares about their feelings and opportunities for ongoing learning and growth, right? All those things that provide tangential value that historically the utility industry has frankly sucked at, right? The idea of remote work is crazy in our industry, right? I'm one that's been fighting for it for years and years, and I'm fortunate to have a remote position. But in the tech industry, for example, that's a standard, right? I'm going to work wherever I want, whenever I want, and I'm going to get my stuff done. I'm a high performer. Otherwise, I don't make it in that industry, right? My wife works in tech. She doesn't hit her quota, she's gone, right? That's the expectation. You are an A+ student or you are fired, right? We see that with Tesla's recent news articles, right? We don't have that in the utility space. I can get by being a D- student, just so long as hopefully I'm not an F student for too long and I need to be in my desk. As long as I'm at my desk, no one really cares, right? There's a lot of other things we can do, continuous learning, all that stuff that needs to be recognized. I know the other thing I was going to highlight here is I know really, really, really smart engineers that I learned from growing up, right? But now we're in a world where everything's power electronic and everything's based on EMT studies and all these new things, grid forming inverters, right? Those really, really smart engineers are saying, I can't do any of that stuff, right? And I'm not being trained to do it, and I don't have the tools, I don't have the education, I don't have the capability, right? And I'm not that old, right? But I feel extremely obsolete in today's world already, right? And it's only been a small handful of years, not a long handful of years. So we need to focus a bit more on, again, like Mark was saying, making sure that the people coming out of academia are really well-trained, well-educated on this new technology kind of stuff. I think we're getting better at that, but also like providing ongoing continuous training to particularly the younger top engineers, right? So that as the technology evolves faster than we even care to imagine, they can keep up with it too, so they don't feel obsolete 5 to 7 years after they start their career, right? I think that's also an area where we don't put much attention.
Jason, I give you last word and then we'll
great.
open it up.
No, this is a really important topic, and I really resonate with all the comments so far. I'd like to pose a challenge that I think our industry and the world of power and energy has really shifted in terms of the discipline itself. And our industry historically has been incredibly siloed. And this is I'll get on my soapbox with how I usually talk to the leaders at GE, because you take a look at our system that historically has been built based on one primary form of generation. And we think about things in silos. Oh, I'm a generation person and that's my world and that's what I think about. But I think, the real need going forward is how to make everything working together. Interoperability is one of the very key aspects. So from a power systems perspective in the past, from education point of view, it's, how do I know how this piece of equipment works? How do I know what the inverter does? Well, that's not the right question anymore. It's how does that work, and how does that work with everything else, to think about systems engineering, systems integration. That's where we really need to go. And I think that's one of the big challenges that we face, because, HVDC, new technologies like grid forming inverters, new capabilities, even with gas plants, with flexibility, right? All of those things are going to really matter, and how it all works together, including grid automation, right? Everything to really tackle the variability, uncertainty, stability, control, markets. It's not sufficient anymore just to say, I know my world, my piece of equipment, and that's it. It's how to find solutions going forward to all of these problems. And I think the disciplines, even in the educational, in academia, really need to shift in looking at very multidisciplinary problems and how to come up with solutions across that entire gamut.
Right. Thanks, Jason.
I just add one
Okay.
I
One
agree.
last one.
I agree completely with what was said, but remember this: it takes time to absorb everything. If you know, there was a comment made this morning that no person knows the whole system, and they're right. And you're trying to create people then who know as much of the system as they can. That takes time. And that's, you know, I'll just put it out there. It's not easy. You can't just, the university is not going to put on courses and change, and the graduates come out 4 years later are multidisciplinary and system wide. They're not. They need the experience, and that, you know, you learn by experience. So it takes 10, 15, I don't know, it takes a long time.
All right, I'll open it up